Assalamualaikum. For chapter 5, volumetric analysis. Okay, for this video is for part 6. Okay, for the last subtopic is calculation for every stage for pH change. Okay, so it includes for strong acid versus strong base titration only. Okay, so the calculation for titration, okay, for your syllabus involve strong acid and strong base. Okay, for example, between strong base sodium hydroxide and strong acid hydrochloric acid, okay, to form sodium chloride, neutral salt and water. Okay, where the pH at equivalence point is 7. So the pH change for every stage. For example, in the first stage we call as initial stage, okay, before titrant is added, means that before titration process is start. Okay, second stage, when the titrant is added. For example, when the titrant is sodium hydroxide. Okay, so when sodium hydroxide as titrant is added, so how about the pH in the solution, pH solution in flask? Okay, next stage, near to the equivalence point. Okay, so how about the pH change? Okay, and then after the equivalence point, so how about the pH change? Okay, so for calculation of pH, for this example, we want to plot titration curve, okay, based on the equation given. Okay, so example, consider a titration of 50.0 ml of 0.05 molar HCl hydrochloric acid with 0.1 molar sodium hydroxide. Okay, so a duration between strong acid and strong base. Okay, for the equation, after balancing, 1 mole of hydrochloric acid react or require 1 mole sodium hydroxide to form 1 mole of sodium chloride plus 1 mole of water. Okay, so where we know for strong acid and strong base, it will produce neutral salt where pH equivalence point is equal to 7. Okay, so for this situation, okay, given a liquid of volume 50 ml of 0.05 molar HCl, okay, actually the volume 50 ml of acid, okay, is in the conical flask. Okay, the volume of a liquid of hydrochloric acid, okay, given molarity, standardized or titrate, okay, with 0.1 molar sodium hydroxide. Okay, so sodium hydroxide as strong base will act as titrant. Okay, will react with strong acid. Okay, so by the calculation of every stages, so we can know how the pH of the solution change. Okay, so we want to plot curve later. So okay, for x-axis is actually volume of titrant. So we know that the titrant is sodium hydroxide. So you must write the volume of sodium hydroxide added in ml, okay, versus pH. Okay, pH actually, we want to check or measure the pH changes, okay, from initial until the end. Okay, and then after calculate, we can plot the titration curve. Okay, so the concept, when we want to measure the pH of solution in flask, now the solution in flask is strong acid. Okay, as we want to know the pH value. So based from video from part 5, okay, the titration curve, there are 4 types. Okay, so this is the first type, titration between strong acid and strong base. Okay, so when the solution in conical flask is acid, so the in your mind you have to imagine actually the curve will like this one. Okay, or from okay, because acid, okay, from initial stage, before and after equivalence point. Okay, because when it is occur when the solution in conical flask is acid. So we go to the question. Okay, first question is calculate the pH at initial stage. Okay, so initial stage means that before base is added 0 ml titrant. Okay, means that the titration process is not start yet. Okay, tak masuk lagi titrant, so, that's why 0 ml titrant. Okay, so what is the pH of solution? Okay, pH solution previously we know in conical flask is acid, titrant is sodium hydroxide. So now the titration is not start yet. What is the pH of solution? Okay, so we want to know the pH of acid. Okay, so the concept, now all the concentration in conical flask now is all about HCl. So concentration of H plus. Okay, so find the pH of this solution. Okay, so this is the initial stage before titration begins. Okay, so because all H plus in the solution, all is the concentration of H plus, so you have to dissociate HCl to its ion. Okay, H plus plus chlorine. Okay, after balance it, 1 mole of hydrochloric acid dissociate 100% to 1 mole of H plus and 1 mole of chlorine. So given molarity of hydrochloric acid is 0.05 molar. So the concentration, because of 1 mole, so 1 times 0.05 molar. So find the pH of this solution. Okay, so pH is negative log concentration H plus. So kita cari concentration H plus. Okay, sekarang semua dalam flask adalah hydrochloric acid, all is acid. So negative log 0.05 is 1.3. Okay, so for every stage you have to know the concept for what contained in the flask. So now because titration is not start yet, so the concentration H plus more, or all is H plus now, okay, because of the acid, right? So in the first point, okay, because later we want to plot first stage for initial stage, okay, nanti nak plot you kena tahu lah what is X and Y axis, okay. So X axis adalah titrant, okay, volume of titrant added. So volume base is 0 ml, okay, because the titration is not start yet, okay, before titration begins, and the pH of solution in flask is 1.3, okay, very acid because all is acidic, okay. So nanti nak plot, you have to know lah for every stage X axis and Y axis, okay, and then the concept. Okay, next the question is calculate the pH after addition of 10 ml of 0.1 molar sodium hydroxide to 50 ml of 0.05 molar HCl. Now the titration is begins. Okay, dah start. Okay, addition of 10 ml. When 10 ml titrant added, so what is the pH of solution now? So there are changes occur. Two solution in acid. Now base was added, so there are changes occur in solution in conical flask. Okay. Okay. So this is stage after addition of reagent. Okay. So we want to know the pH of solution after addition of titrant. Okay. So now addition of base, okay, to H plus. So the concentration H plus still more than hydroxide, okay, because the addition of titrant after titration have start, okay, before equivalence point. So we want to know the pH of the solution in flask. Okay, there's changes occur. Okay, to calculate pH actually from the formula negative log concentration H plus. Okay, so actually this is from concentration H plus from molarity. Okay, so molarity of H plus. Okay, so mole per liter. Okay, perubahan mole yang berlaku divided by total volume in flask. So you will get the concentration of H plus. Okay, so you can find the pH. So initially the volume is volume acid 50 ml. So and then addition of 10 ml of sodium hydroxide. Okay, so total volume now is 60 ml. Okay, this one total volume in flask. So since H plus more than concentration H plus more than concentration hydroxide. Okay, so actually we want to find the number of mole HCl remain after addition of sodium hydroxide, okay, divided by total volume of solution. Okay, so I want to find the molarity, actually mole per liter. Okay, perubahan mol yang berlaku divided by total volume of solution. So number of mole HCl total initial, okay, yang asal, minus number of mole HCl reacted divided by total volume of solution. So, okay, so for number of mole HCl total here, okay, total or initial means that initially in solution, initially in conical flask, okay, the number of mole of HCl initial, okay, from 50 ml of 0.05 molar HCl, okay, we can find number of mole HCl total minus number of mole HCl reacted, okay, actually from addition of base, okay, from addition of base 10 ml of 0.1 molar sodium hydroxide. Okay, since from equation the ratio is equal, okay, 1 mole of sodium hydroxide added equal to 1 mole of HCl reacted. So to find number of mole HCl remain, number of mole HCl total minus number of mole HCl reacted or number of mole of addition of base. Okay, to find number of mole HCl remain over total volume of solution, the number of mole HCl total must be in larger amount and number of mole HCl reacted or addition of base sodium hydroxide must be in small amount. So larger amount minus small amount, you will get the remaining mole. Okay, so we go for the solution. Question B. Okay, after addition of 10 ml of titrant base, what is the pH of solution? So mole of HCl remaining after addition of base, initial mole minus mole HCl reacted divided by total volume. So perubahan mole from initial and mole reacted. Okay, so this is from initial 50 ml and concentration 0.05 molar. So find initial mole. Okay, so given volume 50 ml, you change into liter. Okay, so 50 times exponent negative 3 liter times molarity 0.05 mole per liter. So you cancel unit liter, you will get initial mole. Okay, minus mole reacted. Okay, so remember addition of base. Okay, addition of base actually is from equation 1 mole of sodium hydroxide equal to 1 mole of HCl. So mole HCl reacted is cost equal ratio. So 10 ml change into liter. So 10 times exponent negative 3 liter times molarity, okay, 0.1 mole per liter. So you can find number of mole reacted. Okay, initial must be larger volume minus addition of base or equal with mole HCl reacted. Okay, so you can find number of mole divide by total volume. Okay, in conical flask initial 50 plus addition, so total is 60 ml, change into liter. Okay, because we want to know the concentration. Okay, concentration is mole per liter. Okay, so since HCl more H plus more than concentration hydroxide, so you can find concentration H plus or molarity H plus. Okay, so you will get concentration H plus is 0.025 molar. Okay, next find pH. Okay, concentration H plus 0.025 molar. So find pH, negative log H plus, negative log 0.025 molar equal 1.6. Okay, so in this stage before equivalence point, the concept is because now addition of base small amount and there's more H plus compared to hydroxide, and then don't forget for the to plot later. Okay, for the x and y axis. So volume base added is 10 ml. Okay. pH of the solution is 1.6. When you compare from the initial stage, it has increased, okay, because addition of base, so there are changes in the concentration. Okay, this is x and y axis. Okay, next question number 3, pH and volume at equivalence point. Okay, so when you have to know at equivalence point, concentration H plus equal with concentration hydroxide. Okay, that's why pH equivalence point is equal to 7. Okay, so at equivalence point, you must include the equation. Okay, so find pH and volume. Okay, first we want to find the volume at equivalence point. Okay, means that how much the volume of base added. Okay, at equivalence point stage. Okay, this is stage at equivalence point. So from formula, MAVA over MBBV equals NA over NB. Okay, this is from coefficient. So you have value molarity acid, okay, volume acid, molarity base, and then we want to find volume base. Okay, this is from equation, coefficient of acid and base. So you can find, okay, given molarity, volume, acid and molarity base. This is coefficient acid and coefficient base, since one ratio is 1. Okay, you can find volume acid is 25 ml. Okay, so pH, we know pH equal to 7 as the evidence, since concentration H plus equal with the concentration hydroxide. So the fact is the molarity is 1.0 times exponent negative 7. So, now what is the pH of the solution in flask at equivalence point? Okay, so pH negative log H plus. So negative log 1.0 exponent negative 7 is 7. This is for evidence how pH equal to 7. Okay, from the equal concentration H plus and concentration hydroxide. So later you want to plot volume base 25 ml for x-axis, y-axis, pH equal to 7. Okay. Every stage we have to know what is the stage equivalence point, the concept, H plus, concentration H plus and hydroxide is equal, and to plot. Okay, point to plot. Okay. Next, question number 4. What is the pH of solution after addition 35 ml of 0.1 molar sodium hydroxide to 50 ml 0.05 molar HCl? Okay, so the stage is after equivalence point. Okay, this is the stage after equivalence point. So how about the pH of the solution? Okay, now when added titrant, addition of titrant 35 ml of this, so the concentration H plus and hydroxide contain in conical flask. So the concentration hydroxide more compared to H plus. Okay, so to find the pH, actually we want to know from the concentration. Okay, concentration is from the molarity. Okay, so from the molarity, perubahan mol over total volume in flask. So initial 50 ml, addition 35 ml. Okay, so 50 plus 35 is 85 ml total of the solution. Okay, so find the concentration. Since this is the stage after equivalence point, okay, as titrant was added more, so concentration hydroxide more compared to H plus. So to find the molarity, okay, mole of excess sodium hydroxide is mole of sodium hydroxide added, okay, minus number of mole of sodium hydroxide react or equal with HCl initial over volume, total volume of solution in liter. Okay, remember we want to find the molarity. So since this concentration hydroxide more, so you will find molarity of hydroxide. Okay, so mole sodium hydroxide reacted. Okay, from equation 1 mole sodium hydroxide react with equal with 1 mole of HCl initial. Okay, so the solution. Okay, addition of base. Okay, this one. Molarity of base added. Okay, given volume and molarity. So volume 35 ml, times exponent negative 3 liter, you want to change to liter, times molarity of base added 0.10 molar, mole per liter. So mole per liter times liter, you will get number of mole of base added. Okay. To find mole of excess, mole of base added minus mole of sodium hydroxide react. Okay. So equal with the initial 50 ml of change to liter. 50 times exponent negative 3 liter times volume 0.05 molar LCl. 0.05 mole per liter. So mole per liter times liter, you will get mole changes of base divided by total volume 85 times exponent negative 3 liter. Okay, so actually the larger amount minus the small amount. Okay, or number of mole of titration added, mole titration yang masuk tolakkan mole yang asal dalam conical flask. So since concentration hydroxide more than H plus, okay, we find the concentration hydroxide OH. Okay, so later we'll find POH. Okay, next for the concentration of hydroxide. Okay, so the molarity, after we calculate, we will get the concentration hydroxide is 0.0118 molar. Okay, so because of concentration hydroxide, okay, we have to find POH first, then you find pH. Okay, from the formula, pH plus POH is 14. Alright, so for POH, negative log 0.0118 molar equals to 0.928. Okay, to find pH, okay, to find pH, 14 minus POH. Okay, 14 minus 0.928, we will get 13.07. So for this stage, this is stage after equivalence point, where the concept as more titration was added after equivalence point, the concentration hydroxide is more or larger compared to the concentration of H plus. So that's why when we find concentration hydroxide, we have to calculate POH, then pH. Okay, this is the concept. Okay, next to plot for x-axis, volume of base added is from the statement of equation 35 ml. For y-axis, pH of the solution now is 30.07. Okay, where the pH is basic as more titration was added. Okay, then after you know, okay, when you have all points, so to start draw titration curve, first step, write what is x-axis, what is y-axis. Okay, and then plot first for every point here. Okay, contoh, for example, you plot, and then start to sketch. Okay, plot the point first, then sketch or draw a titration curve. Then after you know the point, pH and volume, we can draw titration curve. Okay, write the x-axis first, volume of sodium hydroxide in ml, and then pH of solution. Okay, so from first 0 ml added 1.3. So plot first. Okay. Next, when 10 ml of titrant is added, the pH is 1.6. Is 1.6 here. 1.6. So plot here. Okay. Number 3, pH at equivalence point and volume. Volume is 25. pH is 7. So third plot here. Next, 35 ml of titrant and volume, not volume, pH of solution 13.07. Plot the last. Okay, and then after that, draw a titration curve. Okay, you adjust this one because small difference. So you must draw very sharp initial, sharp endpoint, and after equivalence point. Okay, for 7, state the equivalence point at pH equal to 7. Okay, so for strong acid and strong base, in sharp from initial and sharp for endpoint, before and after equivalence point. So since the solution in conical flask is strong acid, okay, titrate is strong base. So the curve is like this. For initial, very acidic, okay, because all the concentration of H plus here. Okay, before the titrant is added. After titrant was added, there's a changes in pH, so slightly increase the pH. Now addition of hydroxide, but concentration H plus more than hydroxide. Okay, and then after at equivalence point, okay, concentration H plus equal with concentration hydroxide. Okay, at this stage. So at this stage, for the endpoint, the indicator change color. After equivalence point, if titrant was added more, so pH changes. Okay, so the concentration hydroxide more than H plus. So that's why the pH is increased. Okay, the solution now will be very basic. Okay, so basically there are 4 stages. Okay, first initial, second before equivalence point, third at equivalence point, and last is after equivalence point. Okay, but for the other question, okay, that can be asked, it does not mention what stage. Okay, so how you want to determine? Okay, that question asked is at what stage. Okay, maksudnya kalau soalan tanya, okay, macam mana you nak determine soalan tu berada pada stage mana. Okay, if initial, there's no problem. Okay, because for initial means that no titrant added. Okay, so you can determine the pH at initial, pH of solution. Okay, but how about at before and after equivalence point. Okay, initial there's no problem at equivalence point, because usually question asks you, okay, what is the pH of solution when at initial or at equivalence point stage. Okay, so for example, how you want to determine the question asks at stage before or after equivalence point. Okay, clue, yeah. Okay, you look at this one pada equivalence point, so volume at equivalence point. Okay, contoh soalan previous question. Okay, volume at equivalence point after calculate is 25 ml. Okay, so if question, other question that can be asked, for example, if 20 ml titrant added, okay, what is the pH of solution, or 22.7 ml titrant added, okay, what is the pH of solution. So contoh pada soalan lain tu, macam mana you nak tahu dia berada pada stage mana. Okay, ataupun soalan 26.8 ml. So how you want to determine? Okay, the question does not mention at what stage. So the stage is important because you want to determine the pH letter. Okay, so the clue is find the volume at equivalence point. Okay, so when you have know the volume at equivalence point, okay, you can determine if other question that can be asked. Okay, for example, if 20, so what stage, before or after? Okay, so you look here, when 35 ml is volume at equivalence point. Okay, so volume before 25, okay, mean the stage before equivalence point. Okay, after 25 ml and above, means that the stage is after equivalence point. Okay, so if 20 ml means that the stage before or after. Okay, so berada pada 20, so before equivalence point. Okay, if 22.7, okay, still the stage before equivalence point. Okay, if 26.8, here 26.8 after equivalence point. So if 30 ml added, what is the pH of solution? 30, 40, 45, 60. So this volume is after 25, after volume equivalence point. So the stage is after equivalence point. Okay, why this is important? So based on, for example, the previous question, okay, solution in plus is strong acid. Okay, titrate is strong base. So if at equivalence point, okay, you know the concept, concentration H plus and hydroxide is equal. Okay, so if before equivalence point, the concept, okay, initially H plus increase. Okay, after start titrate, so addition of base, So the concentration H plus is more than hydroxide. Okay, even base was added, but in because of before equivalence point, so the concentration H plus more than hydroxide. Okay, so if after equivalence point, okay, after equivalence point, if more titration was added, so hydroxide more than H plus. Okay, the concept here. So why the stage is important? For example, the question asks you if 25 ml, what is the pH? Okay, so the stage is before equivalence point. So when H plus more, so you just find the pH. Okay, if 30 ml of titrant was added, okay, so the stage is after equivalence point because the volume more than 25, okay, more than 35, so the stage is after equivalence point. Okay, so the concept now, concentration hydroxide is more than H plus, so that's why you find POH and then find pH. Okay, if before, because concentration H plus more, so just find the pH. Okay, this is concept. Okay, if the titration process is like this one, strong base, okay, and titrant is strong acid. So the concept is vice versa. Okay, so if question asks you, so you cannot just assume, okay, that the equation is staged before or after. Okay, so the clue is you find the volume at equivalence point. So any question that can be asked, you can know the stage. Okay, so for example, volume equivalence point is 25 ml. So if addition of 20 ml, okay, what is the pH? Okay, so the stage is before. Okay, after you calculate volume equivalence point, and then if question asks you after addition 20 ml, so what is the stage? Okay, that's not mentioned, so you have to know by yourself. So it is before equivalence point. So the concept, since strong base at the conical plus, so for before equivalence point, concentration hydroxide more than H plus. Okay, so that's why you find POH then pH. Okay, at equivalence point, concentration hydroxide equal with H plus. Okay, so if question asks you after addition of 60 ml or addition of 29 ml, okay, it is the stage after equivalence point. Okay, so the concept after equivalence point, the concentration H plus more than hydroxide, so you just find the pH. Okay, this is the concept is, so if you don't understand, you cannot answer it. Okay, next, draw a titration curve for the reaction between 25 ml of 0.2 molar barium hydroxide and 0.1 molar nitric acid. Okay, So this alicot of volume is in conical plus barium hydroxide. Okay, so this is nitric acid. Okay, so in your mind you can imagine from base. Okay, this one strong acid and strong base. So initially in conical plus is strong base, so the curve is like this. Okay, so when for this question, how do you want to draw a titration curve? Okay, so two stages that you can plot. First is initial, second is at equivalence point. Okay, so find the x-axis and y-axis for both stage. So for example, this one is initial stage. So because of barium hydroxide, dissociate to its ion, okay, and balance it. So 2 mole of concentration hydroxide, you will get concentration. Because of OH, that's why find POH and then pH. Okay, so to plot volume of acid is 0 ml, okay, because titration is not start yet, okay, 0 ml titrant. So pH is 13.6. Okay, later we want to plot. Second stage at equivalence point, okay, must have balance equation and find the volume of titrant, okay, using the formula 3 value known and 1 not 3, this 1 2 3 4 5 value known, and you can find another unknown value. So to plot volume acid is 100 ml, and then pH of solution, you know, 7, okay, pH at equivalence point. Okay, so to plot here pH, this one volume of nitric acid added, okay, in ml. So plot first stage initial 0 ml and pH 13.6. Okay, first plot. Second at equivalence point 100 ml, so pH 7, second plot, and then draw titration curve. Okay, and then mention 7 here is equivalence, okay, point. So draw titration curve. So the things that must be mentioned is x-axis, volume of nitric acid added in ml, pH. Okay, the first plot, this one, and this one, the value pH and volume for the initial stage. For point at equivalence point, second plot, and the correct curve. Okay, the curve must be sharp for initial, before and after equivalence point. Okay, sharp and point, and mention the equivalence point equal to 7. Okay, so you can look another example. Okay, so for example, this question, when addition of titrant 17 ml So you have to determine the stage. Okay, either before or after equivalence point. Okay, does not the question does not mention, so you have to determine by yourself. Okay, so remember what I explained before this, additional notes. So calculate the volume at equivalence point. Okay, so when here is volume equivalence point, so if 17 is before 20, so the stage is before equivalence point. Okay, so because of base in conical plus is base, titrant is acid, this one is from base, so before equivalence point means that the concentration hydroxide more than H plus. So calculate the mole changes. Okay, yang asal adalah conical plus minus addition of titrant. So because concentration hydroxide in more than H plus, that's why you find pH, and that's why you find POH and find pH. Okay, so same for this last example. Calculate pH after 20 ml titrant was added. So this one is before or after equivalence point. 20 volume equivalence point, 22 after 20. So this is stage after equivalence point. Okay, so after equivalence point means that from the concept, the concentration H plus more than hydroxide. Okay, since after equivalence point more titrant acid was added. Okay, so you calculate the concentration mole per liter, perubahan mole yang berlaku bahagi divide by total volume. Okay, perubahan mole, addition of titrant added minus mole in conical plus, okay, yang asal, divide by total volume. Okay, larger value minus small value. So since concentration H plus, so you find concentration H plus here. That's why just find pH. Okay, so that's all for chapter 5. Thank you.